Hey guys, welcome to Chapter 7, Section 1, Triangle Application Theorems. Always remember to apply yourself. Oops. All right, so the triangle angle sum theorem says that the sum of the measures of the three angles of a triangle is 180 degrees. So putting that into terms, what we have with our drawing here, a measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And the way we can prove this is we can draw a line parallel to line BC right here and right here. Okay, and that goes through point A. Right, the parallel postulate states through a point, not on a line, there is exactly one line parallel to the given line. Now we can see in this drawing here that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. Now, we can also see that angle 4 is congruent to angle 1 because alternate interior, given parallel lines, alternate interior angles are congruent. And the same thing is true for angle 5 and angle 3. So by substitution, what we can do is you can take out angle 1 plug it in for angle 4, and we can take out and just bring angle 2 down here, and we can take out angle 5 and plug in angle 3, and voila, we've proven that the sum of the angles of a triangle equals 180 degrees. Okay, so in addition to the three interior angles, there are also what's called exterior angles. And basically those are formed by taking a side and extending it out. So we would say angle 4 would be the exterior angles, angles 1, 2, and 3 interior. Now in addition to interior and exterior angles, there's what we call remote interior angles. So angle 2 is adjacent, it's right next to it, see? But angle 1 and angle 3 are away from angle 4. That's why they're called remote. Okay, they're the angles that are away from the exterior angle, or not adjacent to it. So an exterior angle of a polygon is an angle that is adjacent to and supplementary to an interior angle of the polygon. So this is true for all polygons, not just triangles. That'll wake you up. All right, so the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So we learned earlier that, and we numbered angle 1 and angle 2 because that's at point C, our vertex C of our triangle ABC. So we discussed earlier that angle A plus angle B plus angle 2 must equal 180. We also can look at the drawing and say that angle 1 plus angle 2 equals 180. Well, we know that by substitution, if the one sides of an equation are equal, then the other sides are equal as well. So we're going to put that in play here, and we're going to say that angle A plus angle B plus angle 2 equals angle 1 plus angle 2. Well, by the laws of subtraction, we can subtract identical things from each side. So I would end up with angle A plus angle B is equal to angle 1, thus proving the exterior angle theorem. Okay, and we just did that. All right, so the midline theorem says that if we have a segment which joins the midpoints of two sides of a triangle, it's parallel to the third side, and its length is 1/2 the length of the third side. So in this case, if I tell you that H is a midpoint, so GH is congruent to JH, right? Or if we see something like this in a diagram with these congruent marks, and GM is congruent to KM, all right, or M is the midpoint. We would be able to ascertain then that that's now parallel and HM is 1/2 of JK. Let's prove this. So given H is a midpoint and M is a midpoint, we want to prove that segment HM is parallel to segment JK and that segment HM is equal to 1/2 of segment HK. So the first thing we want to do is we're going to extend HM through M to point P such that HM is congruent to MP. Now, we would say that because you have P, that now establishes or determines PK, right? So PK would now exist, all right, because 2 points determine a segment, right? So first thing we did was we're going to extend HM through P such that HM is congruent to MP, and then because of P, now PK exists. All right. Now what we're going to do is we're going to say, hey, angle GMH, okay, oh, excuse me. So we know that GM is congruent to MK by definition of the midpoint. GH is congruent to HJ by definition of midpoint. So the next thing we're going to state is that angle GMH is congruent to angle PMK because all vertical angles are congruent. Now these two triangles, triangle GMH is congruent to triangle KMP by side angle side. So now through CPCTC, we're going to state that this is congruent to this, so PK is congruent to GH, and we're going to state that, let's go with angle G is congruent to angle PKM by CPCT also. So the next thing we're going to state is that if we have parallel here, so this is parallel to this, right? Because alternate interior angles are congruent. Now the next thing we can see is that we can, since opposite sides are congruent, that this whole figure now we're going to state that JHPK is a parallelogram, because if one pair of opposite sides of a quadrilateral are both parallel and congruent, the quadrilateral is a parallelogram. So, because it's a parallelogram, we can now state that HM is parallel to JK. So we've proven this part. So part 1 is done. Okay, now, since HP, now I'm going to write this out, segment HP is congruent to segment JK, right, by opposite sides of a parallelogram are congruent. We stated earlier that HM is congruent to MP, so we can easily say that 2HM is equal to JK by substitution, right? From there we can divide everything by 2 and we get HM is equal to 1/2 of JK, thus proving part 2 of our theorem. All right, given the diagram is marked, find x, y, and z. Well, the first thing we want to do here, we're going to use this triangle. I'm going to do these in different colors. So the first triangle I'm going to solve for, it'll be this one right here. I'm going to solve for x using this triangle. Well, I know with 160 over here, that measures 160. So because of what we know, we can now say that x is equal to, oh, that's interesting, 20 degrees. Okay? Use the highlighter, why not? I'm going to do the same thing to solve for, with this triangle, to solve for y. So 80 plus 55 is 135, right? Therefore, then y is now equal to 45. Now I know if x is 20 and y is 45, I know that x plus y plus z, let's do this here, so x plus y plus z all equals 180. I can take out x and put 20 and y and put 45 plus z equals 180. Basic algebra. 65 plus z equals 180. Therefore, z is equal to 115. There we go. Find x, y, and z. Okay, ratio problems for triangles. These are really pretty simple. They tell us the measure of the three angles of a triangle in the ratio of 3 to 4 to 5. Find the measure of the largest angle. So you just start off with 3x plus 4x plus 5x equals 180. 3 plus 4 is 7, plus 5 is 12. So we're going to end up with 12x equals 180. If I'm going too fast, well, too bad. So 180 divided by 12 is 15. So x equals 15. But they're asking me for find the measure of the largest angle, which is 5x. 5 times 15, 75. All right, you're going to definitely see problems like this on the test. You're going to see one of these on the oh my gosh, I'm drawing a blank here. You're also going to see it on the final. Jeez, oh Pete, that took a while to get out of my brain. Okay, so here's what we're going to end up with. One of the measures of an angle is 80. Find the measure of the angle formed by the bisectors of the two angles. So we know that 2x plus 2y equals, okay, excuse me, jeez, oh Pete. 2x plus 2y plus 80 equals 180. So I can subtract 80 from each side, and I end up with 2x plus 2y equals 100. Divide everything here by 2, you'll see this. All right. So x plus y equals 50. Now, in the first triangle, by the way, if you're wondering where I got 2x plus 2y from, this whole angle measures 2x, this whole angle measures 2y. Now, I'm going to work on the second triangle, and I'm going to say that x plus y plus angle E equals 180. And they're asking me to find the angle formed by the bisector of the two angles, which would be angle E. Now, I know that by doing this, that x plus y is equal to 50. So 50 plus angle E equals 180. Therefore, angle E equals 130. Okay? You're going to have to figure this out or do this, not just figure it out, but watch this if you have to watch it again. But basically, that's what we do to solve this. We solve the big triangle. We get this figured out. And then we just take this idea and substitute right there. And then solve. Thanks for watching the video. And make sure you do the homework assignment that will be posted to Google Classroom. Stay healthy, and we'll see you soon. Oh, wait, I have one more problem. Psych. Angle 1 is 150. So the measure of angle D is twice that of E. So if this is x, this is 2x. So we're going to use exterior angle theorem. Find the measure of each angle of the triangle. So angle D, angle E, angle F. Well, if angle 1 is 150, angle F is pretty easy, 30. So now it's to find D and E. Well, we know that 2x plus x would have to equal 150. We're using exterior angle theorem. So 3x equals 150. X is equal to 50. Well, angle E is 50, and therefore angle D is 100. Now we're done. Make sure you do the homework. Have a good day.